So in this lesson, we're going to talk about evaluating exponential expressions with signed bases. So let's talk first about some special exponents. So power of 1. So that one is talking about if you have a number or a base, and it doesn't matter what that base is as long as it's a real number, and you raise it to the power of 1, 5 to the first power means you multiply 5 by itself one time, gives you 5. So if you had 107 to the first power, it would be 107. If you had 0 and 8/10 to the first power, it would be 0 and 8/10. So any number to the power of 1 is always going to be that number. The zero power property, let me know if you want me to explain it farther, but zero power property says that as long as the base is not 0, then whatever real number is raised to the 0 power, your output is always going to be 1. So if it's a fraction, like 2/3, and you raise it to the 0 power, it would be 1. If the base is negative, and you raise it to the 0 power, its output would also be a positive 1. So any real number, except for 0, raised to the first or to the 0 power is equal to 1. Any real number raised to the first power is itself. Okay, so sometimes our base might be a fraction and we have to deal with it. And so let's just kind of remind ourselves why this works. So if I wrote out 3/4 squared in expanded form, I get this. But what it's really telling me to do is take the 3 times 3, which means to square it, and the 4 times 4, which means to square it. So essentially, I've distributed the numerator to get the exponent, or the exponent of 2. I distributed the exponent to the denominator to get an exponent of 2. And so I get 9/16. So instead of having to write out the problem in expanded form, we can distribute the exponent to both the numerator and the denominator to get our product. Remember, the product is the answer to a multiplication problem, which is what we call the answer to evaluating an exponential expression. Okay, so now let's talk about signed bases. So first I'm going to write these out in expanded form, and then we're going to look at the product. So if I go ahead and I did the product, that means I'm going to evaluate it. So if I only have one negative, and the number is -2, the product is -2. If I do a negative times a negative times a negative is a positive, so this is going to be positive, and 2 times 2 is 4. If I did -2 times -2, I know that I'm going to get positive 4, so that makes positive 4. But 4 times -2 is going to give me -8. And then if I do these two multiply together, it gives me 4, positive 4. And if I do these two together, I get positive 4. And a positive times a positive is positive, so it gives me positive 16. And then in the last one, if I go ahead and I multiply these two together, I get 4. Multiply these together, I get 4. But then I have 4 times 4, which is 16. But then I have that extra -2. And when I do a positive 16 times a -2, I'm not going to get a positive. I'm going to get a -32. So what's the relationship? Is there a pattern here? Okay, so the pattern is related to something with the exponent resulting in specific signs. So I got a product that is negative, and these were the types of exponents that I had when it was negative, versus getting a product that was positive, and I had these types of exponents. I remember that we already had that rule that said that if we had to the 0 power, so if I did -2 to the 0 power, then my product would be 1, which is positive. So that falls in the category of positive, and that's the kind of exponent I had. Okay, so 0, 2, 4 were exponents that gave me positives. 1, 3, and 5 were exponents that gave me negatives as my base. So what kinds of numbers are those? Well, 1, 3, and 5 are odd. 0, 2, 4 are even. So we can make our summary this way. If our base is positive, doesn't matter if the exponent's odd or even, we're always going to go ahead and get a positive product. If the sign of the base is negative and the exponent is even, like -2 raised to the second power or to the 6th power or to the 0 power, our sign of our product is also going to be positive. So negative base, even exponent. But when the base is negative and the exponent is odd, we got that one negative sign that doesn't get paired up with anything. So our sign ends up being negative. Now, we think, oh, that's so easy to remember, but there's a little catch, and it happens to be looking at the difference between these problems here. Okay, now, I go, okay, looking at the exponents, I see negative signs on all three problems, but I see even exponent, odd exponent. Okay, so what's the difference? Parentheses. Okay, where the parentheses are can tell us a little bit something different. When the parentheses are around the base, this is saying -5 is being multiplied by -5 8 times. When the negative sign is not inside the parentheses, this is saying that we're taking the opposite of the expression 3 to the 4th. Which means I evaluate 3 times 3 times 3 times 3, which is 81, and then I do its opposite, which would give me a negative number as my product. In this case, -81. And right now, I'm not going to worry about for the other two problems exactly what I get. Just want to know if it's negative or if it's positive. So for this one, if I go ahead and I multiply -5 8 times, okay, my base definitely is negative because it's in parentheses. This time over here, my negative was not in the parentheses, so my base was positive. So I need to take care of the negative after. So because the base is negative in the second problem, I go over here and I look at my exponent, and it's even. So negative base, even exponent, it's going to be a positive product. Okay, now I'm going to go ahead and look at that last one, -6 to the 11th power. So if the exponent is even, it's going to be positive. If the exponent is odd, it's going to be negative. So 11 falls in the odd category, which means that is going to be negative. Make sure that you're being careful about when you're evaluating, especially with those negative signs in the parentheses.